Welcome back, everyone. I hope you are having or had a good weekend, depending on when you're watching this video. This week, we're going to continue our Unit P, our preparation unit, with some slope, all right? So I know that you guys know what slope is. You've been learning about this since middle school or maybe even earlier, but you definitely know what it is. If there's anything you forgot about slope, we are going to cover that in the next 2 days, all right? So we're gonna kick this off with our slope formula, all right? Maybe you don't remember the slope formula, but the slope formula is used for finding slope between 2 points. So you have y2 minus y1 on top, and you have x2 minus x1 on bottom. Remember, the y's are the rise. That rhymes. So the rise is on top and run is on bottom. Your x's are your run. So if you see your x, run. There you go. That's how you remember that. So slope. Slope is the constant rate of change, right? Slope is constant. It always stays the same. That's why you have a linear graph. It has a slope. So positive slope means you are going up, right? Negative slope means you are going down. Zero slope means you're not going up or down. It means you just have a flat line, you're going straight. And undefined, so if your slope is undefined, that means you are going straight up and down, right? You're not moving over at all. So this is impossible, right? You break the space-time continuum if that happens. So these are the 4 different types of slope that you could have. So we're going to do some examples here using our slope formula. In order to do this, it's probably best if you start by labeling your points. Oops, that's not x2, that's y1. So we've got x1 and y1 here. X point always comes first, the x coordinate. Then you have x2 comma y2. And then you just plug those numbers into your slope formula, all right? So we've got y2 minus y1, so y2 is 1. And then y1 is negative 5. Now, we did this on purpose for the first example, right? If this is a negative, all right, you're subtracting y1. So you're subtracting negative 5. All right, that's 2 negative signs. And you guys know that if you're subtracting a negative, those 2 negatives turn into a positive. So on the bottom, we have x2, that's negative 6, minus x1 is negative 2. So we kind of have the same situation. So these 2, right, negative signs, that becomes a positive. So we've got y plus 5 over negative 6 plus 2. 1 plus 5 is 6. Negative 6 plus 2, that's negative 4. This is a fraction, but we can reduce this to negative 3 halves. All right, and so that would be our answer for this problem. That would be the slope of the line between those 2 points. Now, another thing about slope that maybe you have forgotten is parallel and perpendicular slope, all right? How do you do that? So if we have an answer of negative 3 halves, what would the slope of a line parallel to that line be? Well, parallel means they're going in the same direction, right? So the slope would be the same, all right? So that's negative 3 halves. Slope of a line perpendicular, all right, so perpendicular, if you remember, that means they're 2 lines that make a right angle. So if you notice, one of our lines is going up, one of our lines is going down, so that means it has to be an opposite sign, and it's also going in a reverse direction. So instead of 3 halves, we're going to have 2/3, so positive 2/3. So perpendicular slope is harder than parallel slope. It's the opposite reciprocal, all right? Reciprocal, as we know, flipped upside down. So opposite sign and flipped upside down. We're going to try one more, all right? Again, we're going to label our points, x1, y1, x2, y2. So let's try this. So we got y2 minus y1. That's 2 minus 2. x2 is negative 1 minus x1, which is minus 11. So interesting thing here, 2 minus 2 is 0. Negative 1 minus 11 is negative 12. And we know 0 divided by anything is 0. So this is actually just a slope of 0. All right. C, we're going to see what happens for C. So we've got, again, x1, y1, x2, y2. So y2 is 8, minus y1 is 5. x2 is negative 7, minus x1 is negative 7. So 8 minus 5 is 3. Negative 7, this becomes a plus, right? That becomes negative 7 plus 7, which is 0. So this time the 0 is on the bottom, all right? So that's the difference between these two questions, all right? With the 0 is on top, 0 divided by any number is 0. But over here, this time it's 3 divided by 0. So how many times does 0 go into 3, right? You can't calculate that infinite number of times. So this is where we say the slope is undefined, all right? So 0 on bottom means undefined, 0 on top means 0, all right? So moving on, all right, we're going to talk about two forms today. This form you should know like the back of your hand, all right, slope-intercept form. That's y equals mx plus b. You learned that in 7th grade. Hopefully you learned that in 7th grade. M, if you remember, is the slope. And b is your y-intercept, all right? So that's where the name comes from, slope-intercept, all right? Point-slope form, maybe you haven't gone over this as much, all right? Point-slope form is y minus y1 equals m x minus x1, okay? So again, m is your slope, that doesn't change, but this time, x1 and y1 is a point, all right? That could be any point. So this is actually a little bit more useful than slope-intercept form. Slope-intercept form can only use the y-intercept, whereas point-slope form can use literally any point, all right? So that's how that works. So we're going to look at some of these equations, all right, and just identify what is the slope and a point, all right? So if we're looking at this problem, okay, slope, all right, what is the slope here? Well, this is point-slope form, okay? If you see these parentheses, all right, that means you're going to be in point-slope form. Slope-intercept doesn't have any parentheses. So the slope is right there. It's right in front of the parentheses. So here our slope is 1/3. And then we need a point, all right? So they're giving us a point. They're giving us the point x1 comma y1. Now notice where those two spots are, all right? y1 and x1, okay? It's the numbers being subtracted. So our x number is right here, all right? Now, this is, again, I'm throwing a lot at you guys today. This might be a little bit tricky. Notice this negative sign, okay? You're subtracting y1. Here, we have a positive sign. So what must we be subtracting in order for this sign to turn positive? We must be subtracting a negative, right? Two negatives make a positive. So your point, all right, is always going to be the opposite signs of what's going on up here, okay? Notice up here, we have two negative signs. Down here, we have two positive numbers. So the point is going to be the opposite sign, all right? That's something you're going to have to remember. So our x1 value must be -3, and then our y value -2, so our y value is just 2, all right? And so that is the point that is being given by this equation. Looking at B, all right, here we have slope-intercept form. There's no parentheses. Y is by itself. So our slope is whatever's in front of the x, all right? That's -5/3. And then our point, so here they're not giving us necessarily a point in the way that they're giving us a point here, but they are giving us the y-intercept, right? And that's our point. The y-intercept is a point. It's just the value when x is 0. So if we're in slope-intercept form, they're always giving us the y-intercept, which is the number by itself. So here, that is -4. So our point is 0, -4, all right? I'm actually going to skip this problem because we're kind of running out of time. So I'm going to come down here, all right, to the graphing. So we're going to go over how to graph, all right? So this was kind of a warm-up, right, what we just did for graphing. So you need to be able to identify the slope and a point in order to graph. So here we have the equation, all right, y equals 2/5 x minus 3. So what did they give us? All right, they gave us slope-intercept form. So our slope is our number in front of x, that's 2/5. Our point is the y-intercept, so we know x value is going to be 0, so it's 0, -3. So when you're graphing, the point is always your starting point, all right, wherever that is. So our starting point is at 0, -3. So we're going to come down here, we're going to plot that point, and then we are going to count off our slope, all right? Remember, slope is rise over run. So whatever number is on top, for us that's 2, you're going to go up that much. So I'm going to count up 1, 2, and then you're going to count over 5 because our run is 5. So you got 1, 2, 3, 4, 5. All right, so that's going to be our new point. And once you've done that, you can count off more points if you want. All right, it doesn't matter, but 2, 1, 2, 3, 4, 5. All right. You can count off as many points as you want to get a good line. If you want, you can count backwards, which means we go down 2 over 1, 2, 3, 4, 5. All right, but once you've gotten a good amount of points, however many points you want, you're going to connect it and draw a line. All right, now a good line extends beyond the points and has arrows. Okay, so don't cheap out and give me a line segment, all right? Draw those arrows. The line's going on forever. Next one, we're going to do point slope form. So in point slope form, we're going to do the same thing, all right? We're going to identify a slope. We're going to identify a point. So in point slope form, our slope is whatever's in front of our parentheses, so that's -0.5. And our point is this number and this number, but remember opposite sign. So our x value is this one. That's where our x is, so that's -2. Our y value is over here. That's -3. So that's where we're going to start. Remember, that's your starting point. So we're going to start at -2, -3. We're going to put a point there, and then we're going to count off our slope. So if our slope is negative, like we have here, that just means our rise is negative, okay? The negative sign never applies to the run. So that means we're going to go down 1. We always go to the right if we're just counting normally, all right? So down 1 over 2. So I'm going to do that a couple more times. Down 1 over 2. And to get a good amount of points. And then we are going to draw in our line with our arrows, all right? So that's how you do point slope form. Very similar to slope intercept form. You're just not starting at the y-intercept. You're starting somewhere else. Last two, all right? What do you do if you have letters by themselves, all right? X equals -3 or y equals 5. So if whatever the letter is, all right, X, okay, the first thing you're going to do is you're going to go to that axis, all right? So this is our X axis, all right? And we're going to go to -3. Put a point right there. Now, this equation is telling us that our X value is always -3, okay? So if you have a letter by itself, that means you're going to have a straight line, okay? It's one of these two situations, all right? Now, which one is it? Okay, that's what you got to know. So if it's X, all right, you're going through the axis, all right? So this, I'm going to draw you what's wrong. This is wrong. You're never going to be over top of the axis, all right? You're always going to be running perpendicular through the axis like that, okay? Because all of these points, this is -3, 1, this is -3, 2, this is -3, 3, right? All of those points have an x value of -3, and that's what our equation is saying. So if it's x by itself, that's going to be a vertical line. For y by itself, y equals 5, so this is our y-axis, right? You can see on our picture. So we're going to go to 5, we're going to put a point, and now you're going to do the same thing, all right? You're not going to run across the axis, you're going to run perpendicular through the axis, all right? So y is going to be horizontal because this is where all the y values of 5 live, right? This is 1, 5, 2, 5, 3, 5, 4, 5. So all the points on that line have a y value of 5. So we kind of threw a lot at you guys today, just trying to jog your memory on stuff that hopefully you learned in Algebra 1. Hopefully this video didn't go too long. I tried to go through it a little quickly. But if you have any questions, all right, bring them to the Zoom session. We can go over any of this stuff if maybe I went over it too fast. All right. Have a great day, and I'll see you guys tomorrow.